Okay, we're going to start by talking through these problem-solving steps. When you are doing a problem, you obviously have to read it. And I think some people don't realize how important it is to just read it and probably read it again. Just it takes a while sometimes to get it completely understood. So don't worry about if you have to read it 3 or 4 times, that's okay. While you're reading, be an active reader, like underline like I'm doing right now. See? Important information. It's really a smart idea to find the stuff that you know is going to be in the problem. Then, if it depends. You don't always make a picture. Okay, if you're going to make a picture, if you've got a rectangle, for instance, definitely make a picture. So if I say there's a rectangle, it's hooked up to a triangle, I mean, I want to draw a picture of it so you can try to see what it looks like. But you don't always need a picture. Write out the equation without numbers, instead with phrases. This is a thing from Mrs. Richens that I kind of liked in her list of how to solve problems. And she just was saying that just write out kind of what you mean. Area of the square, area of the circle. Even if you don't know the formulas, kind of write them out. Equals the total area. That's just like a starter equation. Then you got to get the real equation. And I've tried to hammer on this. You really want it in terms of one variable, x. Like you don't want to have x and y. All right, next thing, when you solve it, which is to solve it like you solve any other equation, check it. Because you got an answer, make sure it actually works in the problem. All right, enough of that. Let's actually do one. I'm going to pause the video for a second while I hand out these worksheets because I didn't want to make up more problems for you. We got plenty on the sheet. I'll work through a few of them with you so that way I can be helping you with your homework. All right, so have something to write with, and hopefully your notes part is done here. We're just going to be working problems together. So what's step 1 as I look at this first problem? Step 1 is read it and reread it. So everybody just silently read it through, maybe even again. Would you agree that it seems like there's a smaller number and a larger number? And would you agree that I'm going to like do something to them and make an equation out of that? Because you see the word equal in there. All right, so now we got to start with, this is a really smart way to go on these smaller and larger problems. Make a little thing that says smaller and larger. What should we call the smaller number? We don't know what it is, so we have to use a variable, right? But which of the two is actually asked for at the end, the smaller or the larger? The larger number is what we want, right? So let's make the larger number x. And the smaller number, then, how do I write that? Well, I got to look here. One number is 5 times smaller than the other. How do I write this as 5 times smaller than x? 1 over 5, what? X. There you go. Or you could say x over 5. It would mean the same thing. All right, you got that written down? All right, now we got to do what it says. If you square the smaller, which one's smaller? This one. We square that and add 6, it'll equal larger. Okay, so I got to square the smaller one. So I'm going to go x over 5 squared and add 6. It'll equal the larger. What's the larger one? X. Does that look like an equation? This looks like something we could graph. Remember, this is a repeat of the graphing test, so it's going to have graphing. All right, question. What you said is, can I have this? Yes, but you have to have the squared on the outside because it wouldn't be 1/5 x squared when you were done. The whole thing has to get squared. See what I mean? The 1/5 has to get squared, and so does the x have to get squared. So this would be okay, but you couldn't have the 1/5 outside like this. No, that wouldn't be okay. All right. So now let's actually put this in on a calculator and see where they cross. It's kind of a pain. I'll tell you, it's hard to kind of see where the two lines cross. But they do. If you use like the Z box on it, I think it'll work. So I'm going to try to pull up mine. That's TI Programs, TI Tools, SmartView, And it's still loading. I'm going to pause till... Okay, so I've got my y equals screen up here. I got a bunch of junk in there. I got to clear out, enter, clear out the old junk. Now put in the new, which is, I need parentheses. You can't just ignore those. And then x divided by 5. And the parentheses, squared. And then plus 6. And then enter. And then the other one's just x. Where's the x? There it is. Duh. And I hit graph. My first shot at it, my window's all messed up. Anybody find a good zoom that worked for him? Zoom 6, zoom 9, zoom 0. Okay, let's do zoom 6 to start with. That's what I'm hearing from people. It does look like they touch up there. Okay. So then I need to kind of get farther over to the right. I'm going to just show you how you can do that with your window button. So I'm going to hit the window button. If I want to go farther to the right, left and right is the X stuff. So I want to get farther to the right, so I'm going to say go over to like 25 instead of 10, and then I'm going to say graph. And then I can see farther to the right. Oh, and I sort of want to get up farther too, don't I? So I'm going to go back to my window. How do I go up farther? Mess with my Y. I'm going to say Y max is like 25. And then I'm going to graph it. See how I'm getting closer and closer to what I want? And then from here, maybe, it's really hard to tell where that's crossing. I'm going to use the zoom box. The Z box. Sounds like you're Dracula when you say Z box. All right. Here. Enter. And then drag the box over around the area that's important. Come on. And then down a bit. What are you doing? My computer's just kind of slow right now. Okay, it touches. In fact, do you see that it touches twice? This is something we did not expect when we made this worksheet. We thought that there would only be one solution to this. There's actually two, and both of them work. Okay, so if you hadn't zoomed in far enough, you thought only one of them worked, we would have given you the credit for it, because it doesn't say find all the solutions that work. Just find a solution that works. Okay, so I'm going to do my second, calculate the intersection, and it'll do one of my two intersections when I just go enter, enter, enter. It tells me that one, which is 15, comma 15. So either way, X or Y, the one I want is X. Either way, it's 15. Okay, so 15 works. So one of my solutions is X is 15. Has anybody, just to save me the time, you go to the other one and you find that, what'd you get for that one? 10. X equals 10 is another solution. Now let's make sure we get this though. The question was, so the two answers were X equals 15 and X equals 10. The question was, one number is 5 times smaller than another. These are not my two numbers. This is one of my numbers. What did I figure out? I figured out X. Look back in the original problem. What did I figure out? I figured out X. There's X. What did I figure out? I figured out 15 is what? The larger number is 15 or 10. Let's start with the 15 thing. So if 15 is the larger number, look over at the smaller number. See how I can get the smaller number? What's the smaller number then? 1/5 of 15, right? Which is 3. So 3 and 15 is a combo that works for that one. Then the real question though is, what is the larger number? So of the 3-15 combo, what's the larger number? 15. How did I get the 3? Okay, we're looking for two number combo here, right? We don't just want number, well, okay. Maybe you were thinking all I care about is what's the larger number. You're right. All I needed to know was that it was 15. And I could have stopped there and said the larger number is 15, done. Why did I get this combo? Because it talks from the beginning about one number is smaller than another number, implying there are two numbers. So what I should really do is figure out what the two numbers are. I figured out that the bigger one is 15, but then the smaller one, it's just smart for me to finish the job and say, well, the smaller one must have been 3. And how can I be sure I'm right? I actually take these and see if it actually works. If I square the smaller one, so that would be this one, right? Square that, what do you get? 9. And I add 6, what do I get now? 9 plus 6? 15. You'll get the bigger one. It worked. See, I can make sure I'm right by doing that. Otherwise, you're right. I could have just used my algebra skills and said, I solved it. There's the answer. But I wanted to double check it and make sure that that actually worked for the problem. Okay? And that's my last step of my steps of problem solving, is make sure it actually works. So let's make sure 10 actually works. 10 is a combo that works. If I make 10 the larger number instead of 15, I pick this to be 10. Then it'd be 1/5 of 10, which would be what? 2. So 10 and 2 probably works, but let's just do it quick. Square the smaller number. What's 2 squared? Add 6. And will it give you the bigger one? Yes, it does. So this works too. But again, what's the real question? What is the larger number? So yeah, all I really needed was the 10. So either you could say 15 and be right, or you could say 10 and be right. All right? So there's a real hardcore word problem. We started at the beginning where we kind of just defined what our two things were going to be, the smaller number and the larger number. And then we made an equation, and then we solved it with graphing. And then we'd look at our two answers. And in this case, both of them worked. What happens when one of them doesn't work? What's it called then? Extraneous. That's going to happen soon. All right, let's go to number 2 together. All right, just read the question. Isn't this a lot like the last one? We got two numbers, a smaller one and a bigger one, right? All right, so what I'd do if I were you, smaller, larger. Do it just like last time, except I don't want to do it for you. I want you to do this one, but I want you to do it later, because this one you can handle. You've already got an example one. Do this one later when you don't have me around. Okay, I'm going to work you through some of the harder ones. Let's look at number 3. This is one that's like an SAT question. ACT, SAT. You want to get into a good college? You got to get a good score on that test. This is on that test. It's apparently one of the real favorites of the test makers. All right, so product of two consecutive even numbers. Okay, wait a minute. Product. I had a couple kids that didn't know what product meant. Do you remember what product means? What do? Multiply. That means multiply. Of two consecutive even numbers. All right. Is 168. All right. So I have an even number. I don't know what to call an even number, but I have a smaller one and I have a larger one, but they're even numbers. All right, the smaller even number, it does give me a good hint here. Let's make the smaller even number 2n. If the smaller one's 2n, consecutive means that it has to be like the one right after that. And so a lot of people's instinct is to say, well, it's 2n and then 2n plus 1. But that wouldn't be an even number, would it? So what do you think it is? 2n plus 2. Good. So whenever they say smaller number, you say that. Whenever they say larger number, you say that. Now, it says the product of two consecutive even numbers is 168. Well, what are my two numbers? They're this and that. And I'm supposed to do what with them? Product, which means times them. Times. And what do I get when I product them? 168. And now I betcha you can solve this. Since it's a solve by graphing test, why do all the long complicated algebra? Grab the graphing calculator, type it in, see where they cross. But be careful, listen. You're going to get an answer like 3. And you're going to be like, but wait a minute, it's supposed to be an even number, but it's coming out odd. The actual number is right here, remember? So if I come out with n as 3, then what's my smaller even number? 6. You get what I'm saying? You're going to take 2 times whatever n is. All right, so that one also, I want you to take from there by yourself. You can handle it. You can work with a friend on it in a minute, okay? So hopefully you got the problem started on your paper. Now I'm going to move on to the next one. Number 4. This is 2 consecutive odd numbers. And same idea, except you don't use 2n. You use 2n plus 1. That'll guarantee that it's odd. Because if you take anything and you multiply it by 2, that makes it an even number. And then you add 1, and that guarantees it's an odd number. You get that? So there's my first odd number. What would my next consecutive odd number be? Yeah, smaller was this one. Bigger is 2n plus not 2, but 3. Because it goes up 2 from this one. You get that? So wherever they say smaller, you use this. Wherever it says bigger, you use that. Okay? See if you can handle it from there. Some advice for you on number 5. A lot of people look at this and say, but that's, if I use this for L1 and this for L2, I'm going to have all these extra lists. Don't think of it that way. Is there some other way to enter this on L1 and L2 so you can do a regression on it? What if you were to take the whole chart it's not going to let me do it. I thought I could rotate it. Can you just turn your head to the side and see that you could write it like a 2-column chart where that's the left column and that's the right column? See how you could do that? Or if you'd rather, tilt your head to the right and then you can see it that way. Okay? So this is like L1 and this is like L2, or vice versa. It doesn't really matter which one you pick as which. You can still enter your data that way. That way it's all on one list. The thing that's important is that 5.9 goes with 175. So it could look like this. Goes with 175. And 6 goes with 177. And 6.1 goes with 180. And 5.7 goes with 170. Getting the idea? Now you can put it in, and now hopefully you already remember this stuff where you put this into the graphing calculator. I want to show this because I think some of you missed that day, and some of the people in the other classes were asking about that. So I'm going to go to Stat, Edit, and I'm going to show you my list. I'm going to put in my numbers, which are 5.9, 6, 6.1, and 5.7. Okay, so I'm going to type those in quick. 5.9, 6, 6.1, and 5.7. Does it matter that they're out of order? Not really, as long as they go with the right thing. 5.9 goes with 175. So I go over here, put in 175. You may as well put this in your list too, because you'll have to do this one with your calculator. 175. And a person who has got a 6 centimeter pinky has height 177. So 177. I actually went around and measured pinkies in the math office. 6.1 is 180. 180. You should see the weird looks you get from people when you say, hey, hold up your pinky. 180. One person made me do it again because she had a freakishly long pinky. 5.7 and 170. For her size. I won't name any names or anything, Mrs. Richens. Okay. And let's see, if I put this into my stat and then calculate and then linreg, then enter. That's how you do it. Stat calculate linreg. And now that gives me my slope is the 24.57 blah, blah, blah. And my y-intercept is the 29.9 blah, blah, blah. And then I got my equation. Once I've got that written, the slope goes here. The y-intercept goes here. And then they ask you a question about it. And if they ask you about, I put these in as the x and these in as the y. So then if they ask me about these kind of things, like they give me a pinky length, I should put it in under x. And if these things I put in under y, so if they ask me about a height, I should put under y. I think they ask you about a pinky length in that problem, so you'd put it under x. And you'd solve it that way. All right. And the last one. This is the hardest one that I want to talk it through with you. And by the way, your assignment is to only do tonight. I'd like you to do 1 through 7. And I've already talked you through several of them. 8, 9, and 10 we can save for a different day. All right. On this one, I know your patience or your focus is waning. Mine is too, but try to stay with me for one more problem, okay? All right. This one is a projectile. What does something make in the air when you throw it up? What does it look like? An arc, a parabola, yes. It looks something like this. If I throw it from this far off the ground, it goes up and then it comes back down again. Okay? All right. So this is the height and this is the time. So if you look at this equation they give you, in the problem it did not label them, but it's still pretty easy to figure out what each thing is. It says this projectile is launched straight up from ground level with an initial velocity of 320. That seems important. And here's the equation. What do you think h stands for in the context of this problem? Height. And so this area is height. At a certain, what do you think? Time. That's the height at a certain time. That's just what? T. Time. That's still time. If it was time over here, then it has to be time over there. This is the height at a certain time is equal to negative 16 times squared plus, what do you think that v is? Velocity. And what do you think, this is a stretch now, but you can do this, the S0 is? 0 implies that it's like the first. Pick a guess. What else do you have to know about where the person was when they were throwing the ball? The speed, we got that. The height the ball is going to go, we got that. All right, it must be too much of a stretch. Yes, their initial starting place. So it's their starting height. The whole graph would be different if you were standing on a cliff and then threw the ball up in the air, as opposed to standing at ground level and throwing the ball in the air. You know what I'm saying? All right, so we needed to know that to be able to do this problem. So now, all I have to do is take this equation they gave me. This is a real classic, like, blah, 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 I'm going to give you a big equation. And then you just stick everything in you know, and it'll be easy from there. Because I know most of this stuff. When will the projectile's height, so I want the height, above ground, where that's assumed, when will it be 1538? Where do you think I should put that height? Can I put it under T? Does that make any sense? No. Is it talking about the starting height? No. So then the only place we can put that, 1538, would be right here. So you'd say 1538 is equal to negative 16 t squared. I don't know the time because I'm going to have to use something else to figure that out. Plus v. Ooh, they gave me a number I haven't used yet. Velocity right here. Velocity must be 320. T. Plus starting height. Did it say where we started? It said ground level. So what do you think we should put there? 0. So plus 0 is kind of not even necessary at the end. Look it, I've got an equation. And this is the graphing test, so what do you think you're going to do? Graph it. So you graph it, you find your answer. Your answer will be a time. And then what if it tells you 2 times? Think about it. Is it possible this could have hit 1,538 feet here and here? Yeah, it hits it once on the way up and then once on the way back down again. So it might have 2 times when the ball was at that height. Now, what if it gave you a negative time? Then would you believe it? No, because then it'd be extraneous. Okay? All right. So you're going to get 2 answers for this. Because it's a quadratic, you kind of expect to. And if both of them are positive, it probably just means that it happened on the way up and it happened on the way down. All right. I think I've given you enough help to get you kind of going on these. I hope you're starting to see some of the steps. You got to think through the problem closely. You got to make a little sketch like I did, if you can. You got to write an equation with 1 variable in it. When you're done, you should check and make sure your numbers actually work. You should throw out anything that's not possible or extraneous. All right. I'm trying my best to help you with these, but they're hard. So it's going to take some hard work. You don't have to get this done by tomorrow, even though. You've got to get 1 through 7 done by Friday. Because tomorrow's going to be a weird day at school. We're going to have all kinds of like plan testing and that kind of stuff. So a lot of you won't even be here. I will have class for those of you that aren't in the plan testing or the college fair or whatever. But and I will have to take attendance. So be careful to not show up unless you're at one of the other activities. And I'm still recording, aren't I? I don't need to record anymore.